Everybody. So today I'm going to be going quickly over what we learned last class, and then I'm going to move on to the next lesson, which is the last lesson you're going to be learning before your quiz. So we're going to be spending the next week, maybe week and a half, reviewing all of the stuff that you learned from graphing, exponents, parts of an expression, evaluating expressions, and then you'll have a quiz at the end, and it'll be a pretty decent part of your grade, as it will be one of the last quizzes you'll have before the end of the first trimester. So here today, evaluating expressions. So let's say we have an algebraic expression, x minus 9. Now usually we kind of just leave it like this because we don't know what x is, so we can't minus 9 from it. We can't minus 9 from something that we don't even know what it is. So this is usually how you leave it. Now in the case of evaluating an expression, they will give us a value. In this case, they told us x equals 15. In which case, you are then going to replace your x with 15. Remember that x is a variable. It's a placeholder for a value you don't know. So now that you know that x is 15, I'm going to place it in there in the place of the x. So now it's 15 minus 9 instead of x minus 9. Remember, this is just a placeholder. Now I know what it is. Then 15 minus 9 equals 6. So that means that 6 is my answer. Now, another thing that you should know is how to deal with fractions. So with fractions, really quickly, just remember that it should be top times top and bottom times bottom. And I'll kind of show you what that looks like here. So we have 6k, where k is equal to 1 over 3. Now, if I were just to replace k with 1 over 3, remember k equals 1 over 3, so I'm going to replace it, I would end up with 6 and 1 over 3. Now remember, if two values are next to each other, we assume multiplication, always. So this 6 and this k multiplied, therefore the 6 and this 1/3 I'm going to multiply. Now it's easier to rewrite a whole number as a fraction like this. This does not change the value. It's just a different way of looking at it. So this is the same as this. It just looks better for what we want to do. And what we want to do is to multiply. Now when you have it this way, you just do top times top, bottom times bottom. 6 times 1 is 6. 1 times 3 is 3. And then we're going to simplify by 3, and we end up with 6 divided by 3 is 2, 3 divided by 3 is 1. So you end up with 2 over 1. If you write it as 2, because remember the fraction version and the whole number version, these are exactly the same. Both of these are fine. You always want to do things in the order of operations. So if you have to do multiple things at once, just remember, if you follow your PEMDAS, you'll be fine. For example, let's look at this one right here. This one looks decently hard. Actually, this one looks harder. So 2f. So we have 4 parenthesis n minus 4 plus 14. And we're going to think of our PEMDAS here. So remember that multiplication and division, they happen at the same time. It just matters which one is on the left and which one is on the right. You always want to go left to right. Same thing with addition subtraction. It's left to right. So for example, little side tangent here. 8 plus 5 minus 2 versus 8 minus 5 plus 2. Now the only thing I've changed is which one is on the left, the addition or the subtraction. Well, in the first case, you want to do 8 plus 5 first, which gives you 13 minus 2. And then 13 minus 2 is equal to 11. Whereas in this case, you want to do the 8 minus 5 first because this is on the left. Not because it's subtraction, not because it's addition, but because it's on the left. So here, 8 minus 5 is 3, plus 2 is equal to 5. So just keep that in mind. And the same thing works for multiplication and division. You always just want to go left to right with these. Multiplication and division, left to right. Addition, subtraction, left to right. In this case, we don't have to deal with that, but it will happen in a couple of the problems, so you have to pay attention to that. But anyway, here, back to this. We're going to go through our PEMDAS. So P, parenthesis. Yes, we have parenthesis. They said that n equals 5. So I'm going to replace n with 5. There we go, 5. So that means 5 minus 4, which is 1. I didn't do anything to this outside here. Okay, parenthesis, done. Are there any exponents? No. Is there any multiplication or division? Yes, because if you remember, if you have two values next to each other, in this case we have the 4 and we have the 1. This is multiplication. Whenever you have two values together like this, it's multiplication. So we're going to do 4 times 1, which is 4, plus 14. And then 4 plus 14 is 18. So it seems like a lot of things to do, and sometimes it can be overwhelming. But just remember, you can break it down into parts and just follow your PEMDAS. Just follow it step by step. P, does it work? E, M or D, A or S? Just do it step by step. Okay, so that's the end of that lesson, and we're going to move on to the new lesson, equivalent expressions. Now, equivalent expressions, let me find my little tool here. Now it says here, equivalent expressions are expressions that simplify to the same value for any numbers that are substituted for the variables. What that pretty much means is, these are expressions that will have the same value if given the same numbers for the variables. Now, for those that find this a little bit confusing, which it is a little bit confusing, I'm going to work this out and kind of show you. So here we have list A. So I'm going to just say whatever, list A. So we have 5x plus 65. We have 5 parenthesis x plus 1. We have 1 plus 5x. Okay, now time for list B. According to list B, LB, we have 5x plus 1. We have 5x plus 5. We have 5 parenthesis 13 plus x. All right. So our job right now is to figure out which one of these are equivalent to each other. And the way we do that is we pick a value for our x and we plug it into both. If they are equivalent fractions, they will have the same answer. So let's see here. I'm going to give each of these a color coding. So this is number 1. This one can be number 2. Yellow is not a good color, so I'm going to change that to purple. That's number 2. Light green can be 3 on that side, and then same thing here. So I'll keep this as 4, and then I'll keep this as 5, and then I'll keep this as 6 on that side, sure. So let's do 1. So let's say that x is equal to 1. Let's keep it simple. So I'm going to replace each one of these x's with 1. So right here we have 5. So this is in red, so I'm looking at number 1 here. There's a little divider. I'll do that in black so you don't mix them up. So 5 times 1, because I put that as my 1, so I'm going to plug that in, plus 65. So remember my PEMDAS, multiplication first. So 5 times 1 is 5 plus 60. That's not a 6. Excuse me. There we go. 65, and then that's 70. Okay, so that equals 70. Next, I'm going to try number 2. So 5 times, parenthesis 1 plus 1. Again, I'm plugging in 1 for my x because that's what I chose. And this will be 5 parenthesis, so 1 plus 1 happens first, so 2. 5 times 2 equals 10, so this is 10. And then 1 plus 5x, that one was in light green. So I'm going to be 1 plus 5 times 1. 1 plus 5 times 1 is 5, so that equals 6. So that's 6. Okay, now, if they are equivalent expressions, then they should come out to the same value if given the same number for their variable. So which means I'm also going to use 1 for this side. So here I got 5 times 1 plus 1, which is 5 times, multiplication happens first, so 5 times 1 is 5, plus 1 equals 6. Okay, oh, that's not a 6. There you go. Equals 6. Then we have purple. 5 times 1 plus 5. So 5 times 1 is 5 plus 5 equals 10. Okay. There you go. And then we have the bottom one. 6. So that's 5 times parenthesis 13 plus 1. Parenthesis happens first, so that's 5 times 14. And then 14 times 5 is 5 times 4 is 0. 5 times 1 is, carry the 2. 5 times 1 is 5 plus 2 is 7. So that's 70. All right. So as you can see, some of these are matching up. Right now, what I have is number 1 and number 6. These came out to the same value. Therefore, they are equivalent expressions. Number 4 and number 3, these also came out to the same value. Therefore, they are equivalent expressions. And then number 2 and number 5, these came out to the same value. Therefore, these are equivalent expressions. So for each one of these, if you want to know if two expressions are equivalent, pick a value for your variable, you plug it in, and see if they come out to the same number. If they come out to the same number, they're equivalent. Now, this is very important because later on, we're going to have to deal with commutative property, writing equivalent expressions, which if you don't know what equivalent expressions are, it'd be pretty hard to create one. Now, here's the part where things get a little bit vocabulary heavy. So if you don't have your vocabulary list next to you, this can be a little bit difficult. So please have it next to you. I'm going to make this a little bit bigger so that I can just zoom down there. Good enough. All right. So one vocabulary that you have learned is term. Oh, that's too light. I'm going to do this in black. So term. And if you remember, a term is a part of an expression that is separated by an addition or subtraction sign. So right here, if they are separated by an addition or subtraction sign, so let's say we got 3y plus 4y. If I were to separate these into terms, I would have to stop at every addition or subtraction sign. So here's one term. I stopped at the addition sign. And then here's another term. I stopped because there's nothing left, and that's the end. So this has two terms. Now, we're going to learn about a specific kind of term called like terms. Now, like terms are terms with the same variable to the same exponent. Now, what that means is if when you have two terms, they have to have both the same variable and the same exponent. So right here, if we have, I'll do some blue, 12 plus 3y to the power of 3 plus 4x plus 2y to the power of 3. First thing we're going to do to figure out our like terms is to separate them into terms. So I'm going to do that here. Again, I'm going to stop wherever there is an addition sign. So wherever there's an addition sign, that's where it ends. Unfortunately, my writing skills are horrendous and I don't know how to keep space. So that's going to clip in on there a little bit, and that's okay. So here, I've separated them into terms. They're each separated by an addition sign. Awesome. Now I'm going to identify which terms are like terms. Well, okay. Which of them have the same variable? Well, it looks like this second one and this fourth one have the same variable. Okay, do they have the same exponent? Oh, yeah, they do. They both have an exponent to the power of 3. Okay, that means that this term and this term are like terms. Let's play a game called Am I Going to Write Legibly? I win. Okay, like terms. terms. Cool. Now, why is this important? You can only add or subtract like terms. If they are not like terms, they cannot be added or subtracted together. So this 12 and this 4x, they can't do anything, interact with each other. They can't interact. They can't add. You can't subtract. However, this 3y to the power of 3 and this 2y to the power of 3, these can be combined. And the way you know how you're going to combine them is the sign in front, this addition or the subtraction sign. So in this case, we have positive 3y to the 3, and the reason I know it's positive is because there's a plus sign right there when I was cutting terms. And then this is positive 2y to the 3. Okay. Now, when you're combining like terms, or when you're adding or subtracting like terms, all you got to do is add or subtract the front parts, the coefficients. This is positive 3. This is positive 2. So positive 3, positive 2. If I put them together, I get positive 5. And then you just put the variable and exponent on the back. So now I've been able to combine them. So now instead of this expression, I can rewrite it as 12, because I didn't do anything there, plus 5y to the 3, because I combined them, plus 4x, because I didn't do anything to the 4x. Now, this and this are equivalent expressions. Now, the reason that they're equivalent expressions is because they have the same value. I didn't change anything. I just combined what I could. So here I have 3 y cubes, which means I have y cubed, y cubed, y cubed. I have 3 of them here. And here, y cubed, y cubed, or sorry, y to the power of 3 and y to the power of 3. I have 2 here, a total of 5, just like what I have here. So don't worry if it doesn't look the same, because mathematically they are the same. And if you need more help in class, I'll go over it, but that's all the time I have for this video. I will see you all on Tuesday, and have a good day.